Alright, so we're supposed to graph this function for 2 periods, and so let's get started. So first of all, we need the period. What is the period? The period is equal to, well, if we had cosine of x, the period would be 2 pi. But, x would be 2 pi for cosine of x. Um, but we don't have x, we have 2 pi x. So that's still equal to 2 pi. So you got 2 pi on both sides, so the answer is x equals to 1. So the period is equal to 1. Now let's do, this one has a phase shift. For the phase shift, I do 2 pi x equals to pi over 4. Okay, so I divide both sides by pi, and I divide both sides by 2. So now I have 1 over 8. So phase shift is 1 over 8. Okay, so the phase shift is taken care of, is 1 over 8. So let's put the phase shift before we forget. So the phase shift is at 1 over 8. Okay, and now I'm going to have my quarter, so 8, the size of each quarter. So I cut the period by 4, so I will have 1/4 for each. Okay, but I like to have the same common denominator, so I'm going to convert my quarter to eighths, so I can add eighths instead of fourths. So I have equals to 2/8. So I'm going to be adding this starting at the phase shift. So the phase shift, well, let me reposition the phase shift. Actually, I'm going to use 1 square for. So the phase shift is at 1/8. Now I'm going to be adding each quarter, which is 2/8. So I have 1/8 plus 2/8. So now I have 3/8. And then 5/8. And then I have 7/8. And actually need one more. 9/8. Okay. Looks like we are ready to graph. So let's take a look. Now we'll take a look at this side. We have a negative, so we need to start at the negative y. And then we have a 3, that's the amplitude. So let's mark the amplitude at 3. 1, 2, 3. And -1, -2, and -3. Okay, so like I said, I need to start at the phase shift. Very important. Don't start at the y. At the phase shift. That's where we start. So, like I said, the cosine starts at the negative amplitude because it's negative. So start right there. We'll start right there. Then go to my first quarter. So I'll just draw a nice little curve. My first quarter. Then my second quarter is actually my amplitude. So I'm going to go to my amplitude. Go this way. The next quarter is my x-intercept. And my last quarter goes to the amplitude again. And I have a weird looking bell. So that's one period. Now, if you want to do another period, just do the opposite. So start at the phase shift and subtract 2/8. So I have 1/8 minus 2/8, that's minus 1/8. And then minus 3/8, minus 5/8. And the last one is minus 7/8. And then I can do complete my my bell here. And I end up at the amplitude. So that's 2 periods. So that's one bell, 1 period, 2 bells, 2 periods. Okay. They also want to know intercept and asymptote. So my intercepts are at 5/8, -1/8, 3/8, and 7/8. And they also want to know my y-intercept. This is very interesting. How to find the y-intercept? Okay, the way we've been doing the y-intercept, according to the book, is to start with the original equation. So I'm going to start with y equals -3 cosine of 2 pi x minus pi over 4. Now, at the y-intercept, x is actually 0. So I have -3 cosine of 2 to pi times 0 minus pi over 4. So this whole expression is 0 right there. So now I have -3 cosine of negative pi over 4. And here's the tricky part. You would think that this one and this one turn into a positive, and then you say, well, I can clearly see that my y-intercept is negative. It's not positive. How can that be? Well, check this out. If you have the angle in a unit circle, pi over 4, okay, the cosine is actually x, so it's positive. And if you have another angle right here, and is negative pi over 4, well, it's the same x here, so if x is positive, so this one's also positive. So in this case, -3 cosine of pi over 4 is actually square root 2 over 2. So the y-intercept is indeed negative, because cosine of negative pi over 4 is actually positive because of the x factor right here. Alright, so we're done. Thank you for watching 27A.